So I'm going to multiply the numerator by cosine x, the denominator by cosine x. Cosine x over cosine x, which is 1. So cosine times cosine is cosine squared x over cosine x equals secant x. Now with a common denominator, sine squared plus cosine squared. But that's a Pythagorean identity that you should know. Sine squared plus cosine squared is 1. So I have 1 over cosine x equals secant x. And cosine and secant are reciprocals of each other. So take it one step further to have secant x equals secant x. Substitution. In place of sine squared, I'm putting 1 minus cosine squared and copying the rest of it down. So that's why this is worth quite a bit, because of that substitution. Then you have to distribute the 2. 2 minus 2 cosine squared x minus 2 cosine x minus 3 equals 0. Now this is a quadratic equation. You want to get it in standard form. So I'm putting the quadratic term first, the linear term second, and 2 minus 3 is negative 1. Do not factor a quadratic equation with a leading coefficient, which is negative. If you multiply both sides by negative 1, you clear that negative, and you get 2 cosine squared x plus 2 cosine x plus 1 equals 0. Now you can factor. You're going to factor this into the product of two binomials, just like we did previous in a quadratic equation. 2 cosine x and cosine x, 1 and 1. And I want a pot, someplace way back here. This is my problem. Copied it incorrectly. That's why it wasn't factorable. All right, now I want a positive 3 cosine, so I make both of these positive. Set each factor equal to 0. Cosine x equals negative 1/2. Cosine x equals negative 1. From the cosine graph, where is the cosine equal to negative 1? At pi. It goes from 1 to 0 to negative 1 at pi for the cosine graph. Where is the cosine equal to positive 1/2? 60, which is pi over 3, but it's not in the first quadrant. We're talking about the second quadrant and the third quadrant. If you put pi over 3 in the second quadrant, what's the angle? 2 pi over 3, and if you put it in the third quadrant, you get 4 pi over 3. We have 3 answers: 2 pi over 3, 4 pi over 3, and pi. So it's not an equation that you're solving. So if you take cosine squared and again make a substitution of 1 minus sine squared minus 3 sine squared minus 3. 2 minus 2 sine squared minus 3 sine squared minus 3. A negative 2 and a negative 3 is a negative 5 sine squared x, and 2 minus 3 is negative 1. Okay, any questions on that one? The b in front of the x, the b tells you how many times you see, in this case cosine, between 0 and 2 pi. That's what B is telling you. How many times do you see cosine repeated? How many times do you see it? 4. So B is equal to 4 because you see 1, 2, 3, 4. And this part 1 question, they're telling you that theta is between 0 and pi over 2, meaning that you're in the first quadrant. And you're given that the sine of theta, which is opposite over hypotenuse, is 3/7. So I have 3 squared plus, whatever you want to call this, x squared equals 7 squared. 9 equals x squared. 9 plus x squared equals 49. X squared equals 40. X equals the square root of 40. In simplest radical form, it would be 2 square root of 10. The tangent is opposite over adjacent, so the tangent of theta is equal to 3 over 2 square root of 10. I can't leave a radical in the denominator of a fraction. This is multiple choice. So I'm going to look for 3 square root of 10, and the square root of 10 times the square root of 10 is 10, times 2 is 20.